All right, so here's 5.3 in case you missed notes. And let's just practice a few problems to make sure you're doing it correctly. 5.3 is just adding and subtracting radical expressions. Simplification is still going to be a skill that we're going to need to use here. Let's take a look at definition of how do we add and how do we subtract radical expressions. There's a nice little definition for adding and subtracting. I wrote just addition, but this is the same rule for subtraction as well. So I'm going to add a subtraction here. I'm going to add a subtraction because it's exactly the same rule. So if I'm adding or subtracting two values, as long as I have exactly the same index and exactly the same radicand, then I can go ahead and add and subtract this values. The index and the radicand must be the same if you want to add it. It's kind of like combining like terms. 2x plus 3x or 5x minus 2x. It has to be the same radical index and the same radicand for us to combine. The rule says if you're adding or subtracting, you can just add or subtract the coefficients. That's pretty much it. The students try to change the radicand, add the radicands, but that is not okay. Okay? So we did some examples in class. I was sick, I remember that. I was sick, so I had a sub, and that's why I am making a video to help you out understand what you're doing here. Most important thing is that the index and the radicand must be the same. If it is not the same, then don't give up so quickly. Maybe you need to simplify it, then they'll become the same. Okay, so I wrote these notes over here for the sub, adding and subtracting radicals. The index must be the same, the radicands must be the same. Sometimes you may need to simplify the radicals first in order for the radicands to become the same. Okay, and then once the radicals are the same, you may add or subtract the coefficients only. The radicals stays the same. So those were my brief notes, and then I hopefully you understood the examples we did here in class. All right. So take a look at just quickly number 9. This number 1, 2, 3. This number 3 right here. We have 6 square root of 11 plus 9 square root of 11. I showed you that you only add the 6 plus 9 and you get 15, but the radicand stays the same. Okay? The radical and the radicand stays exactly the same. So we add and subtract coefficients only. You have a square root of 7 minus 3 square root of 7. Well, it's a 1 minus 3, which is a negative 2, and the radical stays exactly the same. So those are the notes and a bunch of examples. I hopefully you understood. Let's go ahead and do stuff from your worksheet, because I wasn't here. Want to make sure you're doing it right. Let me get some extra scratch paper here just in case I need it nearby. Okay, so let's go ahead and check here. Number 1, let's start with number 1 and then we'll skip around a few things. I wasn't going to do number 1, but here we go. Number 1 says 10 square root of 5 plus 2 square root of 5. So the radicals are the same, the radicands are the same. 10 plus 2 is 12 square root of 5. Right? It's that simple. Take a look at number 2. We have 9 square root of 2 plus 5 cube root of 2. They're saying simplify if possible. It's not every time that you can. Occasionally, very, very, very rarely, but occasionally you'll have one that it's not possible for you to simplify it, and they are not the same. So this one is already simplified. I'm going to write already simplified. Simplified. Students like to write no solution. They abuse this word no solution everywhere. It's not that there's no solution, it's already simplified. Okay? So we're good with number 2. I want to skip around because number 3 is pretty easy, and number 4, if you take a look at it, there's something that they're not the same. So pay attention to those little notes I gave you. I want to go to number 9. I'm sorry, number 5. Number 5 says 9 cube root of x squared minus 4 cube root of x squared. So the indexes are the same, the radicands are the same, and 9 minus 4 is a 5 cube root of x squared. It really bothers me when the students do not write the cube root. They just write square root of x squared. They turned a cubed into a squared because they forget to write the cube root, okay? And this is the answer right there. All right? So simplify things before you add them or subtract them, or maybe you can add and subtract and then simplify. Take a look at number 8. Number 8, they are definitely not the same radicans. They're the same index, but not the same radicans. And that is not okay, but you should try to simplify it before you give up on a problem. This, immediately you see that is 25 times 2. And this is 4 times 2. So I can make sure that I can simplify and then see what we get. We have 11 times the square root of 25 is 5, but then we keep the square root of 2, plus the square root of 4 is 2, and then we cannot take the square root of 2, so it stays in there. So there you go. Now you have the square roots of 2's. They are the same. 5 times 11 is 55 times the square root of 2 plus 2 times the square root of 2. Now we can go ahead and add those two because the indexes are the same and the radicans are the same. So we end up with 55 plus 2 is 57 times the square root of 2. And that is our final answer right there. Okay? So as you can see, don't panic right away and write no solution. That is crazy. You cannot do that. You need to be able to at least attempt to simplify it to the best you can, and things might become the same. Let's take a look at number 12. I don't like how tiny your space is here. I need more. So here we go. We have 75. We have the square root of 75 plus 6 square root of 27 minus 2 square root of 3. Okay? So immediately when I see this is the smallest root here, square root of 3, I can see a square root of 3 and I can see a square root of 3. Okay? It's a hint here. I see that this is 3 times 9, and I see that this is 3 times 25. So we can definitely take the square root of 25. We can definitely take the square root of 9. Let's see what we get here. The square root of 25 is 5, but we have to keep the square root of 3. Plus, we already have the 6 outside, so please don't forget. That is 6 times the square root of 9, which is 3, and we got to keep the square root of 3 in there, minus 2 square root of 3. There we go. So let's go ahead and simplify here. 3 times 6. So we have 5 root 3 plus 18, 3 times 6, root 3 minus 2 root 3. There we go. So when you add and subtract the coefficients here, we have a positive 5, and then we have a positive 18, and we have a negative 2. So that adds up to 23 minus 2. That's 21 square root of 3. Okay, so we only took care of the coefficients, and that is our final answer for this problem, 21 root 3. Be careful with your work. You've got to be very, very, very detailed oriented here. Okay? So let me go ahead and throw that away, and let's move on to a different problem. Let's take a look at number 16. Number 16, we have 4 times the square root of 9x minus 2 square root of x. They're not the same radicand. They're the same index, but they're not the same radicand. But we can see that this 9 over here, we definitely can take the square root of it. So the 4 stays outside. Let's take the square root of 9, which is 3, but we have to keep the square root of x, minus 2 square root of x. 3 times 4 is 12 square root of x, minus 2 square root of x, and 12 minus 2, this 12 minus this 2 is 10 square root of x. And there is your final answer right there. Okay? So that is the nice thing about adding and subtracting. It's a skill that we need so we can move on to the next thing. So adding and subtracting. Okay? Let's see number 18. Number 18, just to make sure you're doing it correctly, we have the cube root of 12x cubed plus 4 square root of 27x cubed. Rule number 1 here, oh, I don't know if it's number 1, but if you look at your notes, you would see that I said the indexes must be the same, okay? And the radicands must be the same. The radicands are not the same. I'm not going to even waste my time simplifying them to try to make them the same because the indexes are not the same. This is already simplified. I cannot add them together. They're cube root and square root. Cannot add them together. Okay? So please pay attention. See on number 17, we have square roots. So we can try to simplify the radicands. But if the indexes are not the same, I'm not going to even waste my time trying to simplify it. I guess they want us to simplify things out if possible. So you know what? I'll take it back. I'll go ahead and simplify, but I definitely cannot add them together. So let's take a look at number 18. We have number 18 here. We have the cube root of 12x cubed plus the 4 times the square root of 27x cubed. That's number 18. So I guess I can go ahead and try to simplify it, but I really cannot add them together. For a cube root, we have to have sets of 3. This is 2 times 6. And then it's 2 times 3. There's not a set of 3 for me. But I can definitely take the cube root of x cubed, which is x, times the square root of 12. Oh, cube root of 12. Plus, that's the square root. And I see that this is 3 times 9. I can definitely take the square root of 9. We have this 4 outside. And we have the square root of 9, which is 3. And this x over here is the same as x squared times x. So we can take the square root of this x squared right here, which is just an x. But this 3 has to stay inside. This x has to stay inside. So it's 3x stays inside. And then as you can simplify a little further, you have x times the cube root of 12 plus 4 times 3 is 12x times the square root of 3x. So I guess I could do all that work right there, but again I have a cube root and a square root. I am not going to go any further than that. So if you want to just simplify things out, you can, but you cannot add them together. Okay, so that's why I'm afraid to even let you try to add them together. You can't. Okay, so that is how you do the adding and subtracting expressions. There's one more here. I wanted to solve it. I ask you to don't do this for now. Save it for later. I want to show you at home. Show you the next class time for us to do it. But if you want to try it at home, go for it. I mean, I'm not going to be upset at you that you went further and tried to solve things. I actually admire if you do that. All right, let's see here. Number 20 is my last problem I'll do here. We have x. Let me do it over here. We have an x times the cube root of 40x to the 4th minus cube root of 135x to the 7th. All right, so let's see what we can do here. The indexes are the same, so now I can try to make the radicands be the same. So hopefully we can get a hint from one or the other here. Cube root, that means I need a set of 3. Let's look for cubed numbers. 1, 8. Oh, I see an 8 here. This is 8 times 5. 8 times 5 is 40. I can take the cube root of 8. X to the 4th I can write as x cubed times an x. I'm always looking for cubed values. And let's see what we get here. So we have an x outside times the cube root of 8 is 2. So I took care of the cube root of 8. I'm done with that. The 5 is going to have to stay inside. So cube root of 5. The cube root of x cubed is x, but this one is going to have to stay inside. So there we go. Okay? So I simplified this first radical. And if you want to go ahead and multiply 2x times an x is 2x squared times the cube root of 5x minus, Now, it would be nice if we could turn a 5x out of here. 135 I know is divisible by 5. So if you grab your calculator and you do 135 divisible by 5, you get 27. So that's nice. 27 times 5, because I see this 5 right here. And the x to the 7th power is x to the 6th times the x to the 1st, because I know the 6 can be divisible by 3. So let's go ahead and take the cube root of 27, which is 3. The 5 is going to have to stay inside, so I'm going to put the 5 back inside. Took care of those two. 6 divisible by 3 is 2, so is x squared. The x is going to have to stay inside. I know I am making sense because my radicans are the same, cube root. The index are the same, the radicans are the same. Minus 3x squared, squared, cube root of 5x. There we go. So I know we're doing this right because we got the same exact radicand, and we even got things outside that are pretty similar that we can add and subtract them, okay? So if you have a 2x, okay, I'm going to do it on the side, a 2x squared minus a 3x squared. Sometimes the students just don't see this. I have this, and I'm combining with this right here. That means it's a negative x squared. So I have a negative x squared and the cube root of 5x. And that's all there is to it. Okay? There's all there is to it. I combined my coefficients and I kept my radicand and my radical the same. Okay? So all that work to make the radicands be the same, so you can go ahead and work with the coefficients. Okay? So the answer for number 20 is negative x squared times the cube root of 5x. Okay? Show your work. Make sure you show your work so I can see that you're not just copying the answers. So, and that is it for the division. And I'm sorry, for the adding and subtracting radical expressions. So good luck. Finish your worksheet. That's it.